Welcome to Study Loop.
Let's evaluate the integral by first using a substitution and then possibly using partial fraction decomposition for the rational function. So here, let's take u to be square root of x, which we can go ahead and write as u squared equals x. And taking a differential on each side, 2u du equals dx. So we can replace dx in the integral with 2u du. So this integral becomes 2u du up top. On the bottom, we see an x squared there. So let's take this equation here and square both sides. So that means x squared I can replace with u to the fourth power. And then we see an x. That's just u squared. And then we see square root of x. That's just u. Let's go ahead and simplify this. Our new integral, which is now a rational function. We can take a u out. We can factor out a u in the denominator. And we could even cancel a u here. So now we have 1 over u squared, u plus 1, du. Now let's go ahead and do a partial fraction decomposition on our rational function. So we have 1 over u squared, u plus 1. That should be the form a over u, b over u squared. So this is what the author calls case 2. For the first term, that's a u squared. That's a repeated linear factor, u. And then we have a case 1. This is a non-repeated linear factor, so we just get c u plus 1. Taking our new equation, let's go ahead and multiply both sides by this denominator in the left. So we have 1 equals au, then u plus 1, b u plus 1, and then we have cu squared. Let's go ahead and maybe simplify this, expand the right-hand side. And then combine like terms. Here, let's plot a u squared, a plus c. Let's plot a u, it's a plus b. And then we're left over with b. And this is where we'll get our system of equations. On the right, we have an a plus c in front of the u squared, but there is no u squared on the left. That means a plus c is 0. Similarly, a plus b is 0. And then we must have b equals 1, the constant terms. So that's a 3x3 system. Let's go to the next page to solve this. So we had b equals 1, a plus c equals 0, a plus b equals 0. So go ahead and solve this for a. We have a equals negative b equals 1. So we get a negative 1 here. And then c equals negative a, but a is negative 1. So c is 1. So now we have a, b, and c. Let's go ahead and plug in those values, a, b, and c, into our partial fraction decomposition. So we had previously pulled the 2 out in front of the integral. Now we have a over u, b, which was 1 over u squared, and c, which was also 1 over u plus 1. There should be a 1 up there. Let me go back. I'm starting to look like a 2. 1 over u plus 1 du. Now, for the second integral, we can use the power rule. And if this plus 1 is bothering, you can do a u sub here. So go ahead and evaluate those three. For the first integral, -2, natural log absolute value u. And then for the next one, we get -2 over u using the power rule. And then for the last one, 2 ln u plus 1 plus c. Now we could go ahead and replace u with how it was defined. Recall, we defined in the beginning of this problem. So let's go ahead and replace u. And instead of writing square root of x, let me write x to the 1/2 here. And we'll see why in a second. And then we have 2 ln and then square root of x plus 1. And here I'll drop the absolute value because 1 plus square root of x is always bigger than 0. And then plus c. So the last thing you could possibly do here is rewrite ln x 1/2. Go ahead, we could even take the 1/2 out of the absolute value. And then write this as 1/2 ln x. So when we do that in our problem, the 1/2 will cancel with the 2. So we just have negative natural log absolute value minus 2 over radical x plus 2 natural log radical x plus 1 plus c, and that's our final answer.